Good morning, dear students. Welcome to another session of Computer Networks Lab. So, in previous session, we gave a brief introduction to NCTUns tool. Then we conducted two experiments. That is, first and the second experiment, in which we had seen the communication using TCP to TCP. That is, sender TCP and receiver TCP. And next, in the next, we had seen uh, a overall network which makes use of TCP and UDP protocols on different nodes. So let us move further and look out what is related to experiment 3, in which we'll be looking out to try to simulate an Ethernet LAN, that is local area network, using n number of nodes. In this case, we can choose the nodes to be around 6 to 10 and try to see what are the statistical parameters and how they are related, what is happening. So this is what we'll be checking out in this case. So again, as we had discussed in introduction part, we have to switch on to the VMware, then to Fedora, and then through Fedora go to NCTUns. And once you come to NCTUns, open the terminal, and in that open the dispatcher, minimize the terminal, open new terminal, and open the coordinator, and then minimize the terminal and open new terminal and type NCTUns client command and press enter. So wherein the tool what you are observing here will be visible. So now it is available for us for the operation to be conducted. So I'll just take a new file now. So in this new file, so we have to simulate a Ethernet LAN. Now in this case, I have a shortcut method, as previously we were having different specification wherein we were connecting the host, and in between we had routers. We had used the hub. Now let us go a little bit higher, wherein we'll be establishing the communication between the nodes with the two-layer device, which is called as a switch. The two-layer device will include the physical layer and the data link layer. So here uh, you can just see. So previously we had used all these options. So now let us move further. So here we can see one icon which specifies create a host subnet. So if I just click on this and click on the editor screen, I'll be presented with some parameter. So I wanted to have a Ethernet LAN with around 6 to 10 nodes. So let us consider 6 nodes, number of hosts, and this you can alter as per your requirement. So if I click OK, so the configuration is created for me. So this is the topology what we have created now. Now here we can see that this symbol what we were using previously, we were using a hub. Now we are using a switch. Hub is a one layer device. Switch is a two layer device. Hub has only the physical layer, whereas switch is having the physical and the data link layer. Now we can see that there are a number of hosts which are present here. And now we have to configure few of them as sender, few of them as receiver, one using the TCP, one using the say UDP. So you can configure in this way as we had done in the previous experiment, that is experiment 2, and try to see what is the overall result what we are getting. So let us try to configure few of the devices. uh, so we can observe here. So in order to edit the topology, so click on edit. So it will ask for the file name. So go to root, and under this I'll save this as the experiment 3, Rudra experiment 3. So I have saved this. So by doing this, IP addresses will be assigned. So I can just cross verify the IP addresses once. So the host 2, so what we are looking here is 1.0.1.1. This is 1.2, 1.3, 1.4, 1.5, and 1.6. So we should know whom we have to send the information. Say what I'll do is I'll consider host 2 sending information to say host 2 sending information to host 3, and host 6 sending information to host 7. So let us see what happens in this case. So as per the previous discussion of the introduction, so double click on the node, click add. So let me use it as a sender which makes use of TCP. Yes, TCP hyphen P. Let the port number be 2000 hyphen L 1024. So I'll be sending it to 1.2. So this information will be sent to the node with this IP address. So now I have to do the changes with the node editor. Click node editor, click MAC 80223, make it full duplex. Select this collision drop packets, say outgoing throughput. So I'll try to see these statistical parameters. When you come here again, remember, don't close the window, you just press enter. So now click OK. So this has to be made as a receiver. So RTCP sorry hyphen P. So let this be 2000 L 1024. Okay. Okay, sorry, I'll modify this. So let this be 30. Okay. So node editor Mac, then full duplex log packets. I'll be having a collision drop and incoming packets. So again press enter. Okay. So this is one set which has been configured. Now you can do the similar kind of configuration to others, say one using TCP and one using, you can change the port numbers and try to establish the communication. So what we can try out here is say I'll make this sorry, modify this one. So I'll be doing this as stg hyphen u user datagram. Then the length of the datagram and for how much seconds, and then to whom, say 1.0.1.6. I'll be sending it to this one. Suppose if I configure this as a receiver for TCP, so I'll not confuse this one. Sorry, I have to do the node editor. So go to node editor, click on MAC 8013 full duplex log packets, collision number of packets, and see the outgoing packets. So press enter here. So we have configured the sixth one. Let us configure this one, add which is 30. So since somebody has to receive this, that is I am sending data to the host 7, so I have to configure this as a receiver. So I have done that. Go to node editor, MAC 8023 log packets and incoming. So these I'll be storing. So I have just configured. So you can try out different configuration using different port numbers, using different classifications over there. So now once we are done with this, so let us go to the run mode. So in order to do that, click on R. So it says save the topology. So let us save. So once this is done, press enter. So now we are in run mode. Let us see what happens when we try to click simulation and run. So you can see that the simulation starts to run. So let us wait till it gets over. Okay, simulation is done. Okay, so all the logs have been created. So I'll try to just play back, either click this P button over here or just click this button. You can see that some data exchange will be happening. So let us see what that red indicates. Now red indicates that data has been transmitted, but it is not intended for those nodes, so they will not be accepted by them. So there will be a dropping of the packets at those nodes, and if any packet collision occurs, so it will be appearing as a cross mark. Okay, so I'll just stop it here itself. So simulation has been done, so we just saw what is the overall simulation. So let us go and see the graphical analysis of all these statistical parameters. So again, go to G tools, plot graph, file, new. So the name given was Rudra example 3 dot. So I have to check out for dot results. So under this you'll be having all these parameters. So let us check for drop. So okay, no drop has happened at this node 2. Let us check for collision. So collision, no collision has happened as per the graph statistical parameters what were taken. So here we can see that we have the output throughput what is specified. So we have it in say kbps. So file open. So these are the different parameters what you can check out. Okay, so what, so these are the graphical analysis what we have. So these are the things which are available in this case. Now you can slightly observe that collisions and drops are reduced to some extent, because switches are slightly smarter than hubs, but still not smarter than the routers. uh, so that is what we can check out. So this is the experiment as related to experiment 3, wherein we simulated the Ethernet LAN using around 6 nodes and observed the various graphs. So let us wind up this session here itself. Thank you.